Hello, this is Team 8 of Kim Hye-won, Lee Nam-hoon, Choa La, and Justin Chan. Welcome to our final presentation of the Haider Aliyev Center designed by Zaha Hadid Architects. To begin with the location, Baku is the capital city of Azerbaijan. It is a city rich in tradition and trade, located next to the Caspian Sea and filled with historical palaces and artifacts. The Haider Aliyev Center was proposed to be built in Baku as a new multi-purpose cultural center that would host local and global events for not only the city, but for the entire country. The center aimed to be a representation of the future landscape of Azerbaijan, breaking away from the old traditions that were left behind from decades of being ruled by the Soviet Union. It served as not only one of the keystones of development for the country's new independence, but as a movement of optimism for the country's future arts and culture. Moving on to the design, the main design core of the center is fluidity. The building aims to blur the lines between an architectural object and urban landscape, providing a flowy aesthetic that could transition between both easily. The fluidity concept was to be applied on the exterior as well as the interior, as shown in the shapes reflected on the building's roof and walls. The fluidity creates an irregular shaped building that is unlike traditional rectangular shaped buildings. This is known as a free-form building. Thus, our topic of the semester is the engineering design process behind a free-form building. In our presentation, we will discuss about the overall construction process in order from the foundation to the interior, covering all aspects of the design of the Haider Aliyev Center. First, let's begin with the foundation of the center. In 2007, construction began by the groundbreaking ceremony of the Haider Aliyev Center, where President Ilham Aliyev laid the first stone for the foundation. Soon after, land excavation and the installation of the foundation began. Baku is known for the strong winds and earthquakes, so it was imperative that the foundation was strong enough in order to support environmental loads of the building. For this, they used 150-foot long concrete piles, rated to withstand the earthquakes up to 7.0 magnitude. Now, let's move on to the next section, covering the structural systems of the building. The Haider Aliyev Center consists of two main structural systems that collaborate to provide the overall strength and frame of the building. One is a concrete structure shown on the left, and the second is a steel space frame as shown on the right. The concrete structure is a support system made of simple concrete structures in a layered design to provide support for the flooring and walls of the building. This is typical in traditional building design, but the main focus of the concrete structure was on dividing the building into the three sections of the museum, library, and auditorium. The space frame is primarily used to support the external facade of the building, as well as provide the most structural strength needed to withstand environmental loads and distribute it to the foundation. To design and construct the space frame, a BIM, or Building Information Modeling solution, is first needed. Fabrication of the space frame members then proceed with the installation, being the last part of the construction. Here, we will briefly introduce how to divide the space frame grid with BIM. First, 9-meter offset grid lines are drawn in the X and Y axes. Each intersection of the grid represents a node, where the two members of the frame will meet. In the second step, a grid of three-dimensional diagonal elements are inserted to create the 3D shape of the building. The geometry is constantly checked for clashes with the architectural shape. After the geometry is finalized, A finite element model is then generated and computed. The finite element model goes through stress analysis simulations, according to the conditions and codes required. Next is the fabrication of the space frame. To create the shape of the external skin, 5.5 thousand tons of structural steel was required. The steel members used in the Haydar Aliyev Center are all CHS members, also known as circular hollow sections. Circular hollow sections compared to square or rectangular hollow sections are more advantageous because they offer a stiffer geometry using the same mass. Due to the nature of the complex geometry, the length of the circular hollow sections vary greatly and can reach up to 4.5 meters in length. In addition, each member can weigh up to 22.5 to 450 kilos each. All the steel members are connected by a Mero-KK node at each intersection. The nodes of the Mero system are spherical in shape but with flat surfaces all around for bolt holes. This allowed the steel members to connect at the nodes in many different orientations, allowing the final space frame structure to follow the beautiful fluctuating shape of the facade that is designed to hold. Lastly, the installation of the space frame. To erect the space frame, the scaffolding method was used. Each individual space frame element needed to be assembled in place at the actual elevation and final position it was meant to be at. Cranes are used to lift the steel bars into place, where it is fastened and assembled by ironworkers on temporary scaffolds. Next, we move on to the construction of the facade, or exterior of the building by GFR panels. GFR panels are known as glass fiber reinforced panels. They are made of concrete and glass fibers and are the panels that cover the entirety of the Haydar Aliyev Center. The overall construction process of the GFR panel is highlighted in the above process. We will go over the process while focusing on the substructure of the panels. In order to create the facade of the center, GFR panels need to be curved in up to 3 directions that are all unique to each other. Compared to traditional panels that may be flat or curved in a single direction, this is an extremely complex, as creating the system of panels and manufacturing each unique panel requires special techniques. First, to create the design of the entire panel system, the process of paneling the curved surfaces of the center's design is necessary. Using generative design, this can be achieved. In generative design, inputs of the geometry are used to generate a certain number of outputs that can meet certain design constraints. This process is used as a designer that will fine-tune the feasible region by changing minimal and maximal values of an interval in which a variable of the program meet the sets of constraints. Compared with traditional design that requires a manual process and calculation of the geometry needed, generative design uses software that autonomously creates an optimal design based on the system requirements. The contractor develops a Grasshopper script to automate a process which translates each 3D panel needed within the 3D model. After the design is finalized, then manufacturing the panels begin. For step 1, the CAD from the generative design is transferred into the molding equipment. This is done by using a special plugin on Rhino. The 3D laser projector shoots a continuous laser beam that spans the membrane surface, providing the geometry of the edges of the panel. 4 mold edges are then positioned along the laser line. For step 3, the reinforcing glass fiber is sprayed in the frame and then the concrete is poured after. In step 4, after the material is hardened and cured, it can be removed from the molding panels. The surface is then cleaned and finished to be ready for transportation to the site. Lastly, let's move on to the installation of the panels to the facade. To get to the construction site, The panels are transported by diesel trucks all the way from Hamburg. At the site, cranes are used to lift the panels into position. Although the building cladding was specially manufactured, no special fastener systems were required. They used standard bolts and screws, standard drill anchor systems for the concrete, and so on. In the assembly process, the insulation panel is first assembled. After the insulation panels have been installed, a secondary structure is added as a support, and then lastly, the GFR panel is cladded on top. After covering the construction of the vacated building, it is time to move on to the interior construction of the building. The interior of the building is shaped very similar to the exterior of the building, due to the facade geometry translating directly into the ceilings of the interior. Due to the concrete structure, the fluid-like interior of the building is divided into an auditorium, a library, and a museum. Among them, we focus on the construction methods used in the auditorium and library to tailor the visual and audible experience. One of the biggest issues that needed a solution was the auditorium and library being in such close proximity. Because the auditorium housed concerts, recitals, and speeches, the noise must be isolated from the library where silence is needed. To make this possible, box-in-box construction is used. In the construction of the auditorium or concert hall, an additional 6 soundproof concrete walls that are 60 centimeters thick were placed around the room. By doing this, it housed the concert hall in an enclosed box separate from the library. In addition, 12,000 square meter layers of rock wool insulation was used to further increase the sound dampening. Lastly, let's look at the interior lighting design of the Haydar Aliyev Center. During the day, a giant glass curtain wall allows sunlight to fill the interior, providing all the lighting that it needs throughout the building. At night, self-lighting is required through the use of LED luminaries. To create the giant glass curtain wall, it begins with a concrete primary structure that is a part of the main structure of the building. Next, a secondary frame is attached with horizontal beams called transoms and vertical beams called mullions. Lastly, pre-assembled glass units are attached to the transoms and mullions to construct the final design of the glass curtain wall. The glass panels are pre-assembled by means of a unitized curtain walling system. This manufacturing method provides very high-quality units that are able to be transported to the site and installed easily. The pre-assembled glass units attach to the transom and mullion frames by using a permanent sliding support bracket. Switching to the nighttime, LEDs are used to light the interior of the building. The goal of the interior lighting design was to fuse the lighting within the fabric of the building so that it enhanced the flowing nature of the single surface that encompassed the building. To achieve the lighting in the Haydar Aliyev Center, they used T5 lamps that are versatile lamps which are able to emit light in multiple directions depending on the application. T means 1/8 of an inch, and T5 means a lamp with a diameter of 16 millimeters. When designing the buildings, the architects designed a large floor trough, which separates the skin from the floor at the base of the building. As seen in the images, the troughs allow for a small hidden section for lights to be installed. The LED light strips are assembled into the troughs by an aluminum profile support and a diffuser on top to scatter and soften the light emitted. The final product is a hidden and seamless lighting design that is able to fit into the edges of the floor without obtrusive supports. The lighting troughs work well by reflecting the light emitted by the LED off a wall and then into the space. Normally, lamps are used as a direct lighting method, but the reflective lighting carries a soft glow that is essential to the design and aesthetic of the Haydar Aliyev Center. For the ceiling lighting, ceiling slots are used to integrate lighting structures directly into the walls without any additional supports. To achieve this, the designers designed a frame to be drilled into the walls and a bracket to secure the lighting device on the ceiling hole. From there, a channel can be attached to the frame. In the channel structure, the batten is then inserted, which is the lighting assembly. Inside the batten, the T5 lamps are mounted. This concludes our presentation. Thank you for listening.